Okay, good afternoon, everyone. So today we are going to have another academic lecture. Before we begin, I'm going to introduce our speaker, and I'm also going to tell you about the things that we will learn for today. So the title of the presentation for today is Super Resolution, Spotting the Unseen, Seeing the Unthinkable. And just to give you a very brief idea of what the talk or the academic lecture is all about, let me give to you the abstract of the presentation. So this lecture will give insight into super resolution's inner workings and applications in different contexts. Attendees will be given knowledge on how super resolution works across different images, such as those with low pixelation or lighting differences. So throughout this talk, we're going to talk about different scenarios of or different use cases of super resolution. We're going to understand what super resolution is, different applications of super resolution. So for those attending this lecture, you should have a basic understanding of machine learning concepts, especially hyperparameter tuning and how do we train our models. So let me introduce to you our speaker for today. Our speaker is Ricardo Luis Vicerra. Ricardo is an undergraduate student at Salle University, pursuing a degree in computer science as part of the ladderized honors program, BSMSCS. Tentatively, his thesis topic revolves around improving computer vision object detection, and he is currently investigating super resolution as a means of improvement. So without further ado, I'll give the floor to Ricardo. Ricardo, you may start your presentation.
Thank you, sir. So allow me to just share my screen 1 second. So is this visible to everyone?
It's still,
Okay naman.
yeah,
Yeah,
okay.
okay
Okay.
naman. Okay. So hello everyone. I'll be giving this talk towards super resolution, and essentially what I'd like to emphasize is really just the captivating aspects of this technology, because at least for me, before I even thought about using this for my thesis topic, this was one of the more, how would I say, profound things regarding the field of computer vision that I was particularly interested in. So actually, before I start the talk itself, I just wanted to have a little bit of an interactive segment. So this is more of just an icebreaker. I have 3 images, and I just want you guys to type out what you're noticing across the images themselves. So here is our first image. It's an image of what I would presume to be a hotel, resort, pool bench. And I just want, if you guys could type in the chat, what do you guys particularly notice about this specific image? Like, what do you notice about its quality, its colors? I'll give you guys like maybe 10, 20 seconds to type. So I want this to be a bit more interactive in a sense, just to have that sense of communication, and at the same time, because I'm probably going to yap a bit towards the applications, and I just want you guys to have a little bit of engagement towards the start. So I'm not seeing chat, or am I able? Yeah. Um, would anyone please point out what you're noticing? Sort of pixelated, yeah. So as you can see, it's a bit grainy, and there's definitely a difference, or how would I say, if you guys would consider it like this could be 480p or somewhat lower quality, and warm or bright colors, yeah, there. Low resolution, okay, that's the main thing that I want to drive home. The pixelation and the low resolution. In comparison, you guys don't need to comment about this. This is what it looks like when this particular image is super resolved. What's the immediate thing that comes to mind? First, it's going to be the lack of pixelation. So I'm just gonna go back and forth between the two. You're immediately gonna notice how you're not seeing all of those streaks of pixels. Like for example, if I can annotate. For example, here you're gonna notice that if I go back, you're gonna notice that the particular like shadow lines, they're not just gonna be like what you would presume to be like pixels that are like uh back and forth stacked on top of one another. The minute it's super resolved, you're gonna see a clarity towards the shadows. Similar similar things actually happen towards the chair itself, and at the same time the lines of the towel, and at the same time this ring. So you can notice, even if it's not like super zoomed in, you could particularly see the pixels in that small ring at the top of the chair. And the minute you have it super resolved, you can just see it as a normal ring without any sort of disfigurations towards it. So this is somewhat of a similar thing. I just want you guys to just bring up the same thing if you notice that this happens in the next two pictures. So this is our next set of pictures. Could everyone please type what you're particularly noticing? Is it the same thing? Or would you say that there's something different towards this image? You could probably immediately assume that the same is happening, but is there any particular segment of the photos, blur, that's a big one. Is there a particular segment that just stands out? Yun, lack of focus. So blur and lack of focus in particular are especially things that happen to our cameras. So for example, imagining you're gonna take a photo and there's a little bit of motion blur. This can cause these kinds of disfigurations and like this lack of quality towards our images. So same with the previous one. Here's the super resolved version. So as you can immediately notice, like the minute you're applying super resolution to images, it's already it's already as if the image had focus to begin with. So that's one of the particular beauties that I find in super resolution, because an image that lacks a particular focus and it doesn't necessarily feel like it's that amount of quality, especially for today's day and age of cameras. Super resolution is able to refine those details and take out these blurs, these imperfections, and this lack of focus. The final image is particularly blatant, so I'm not going to ask you guys to say anything, but immediately what I'm going to presume you would have said is the pixelation for one, because it's very blatantly pixelated that this could probably pass off as a pixel art. And at the same time, the blur also comes into play again, because while it's pixelated, there's also the sense that it's very blurry. And let's just look at the super resolution. It's like that. So this is a particular instance of a very powerful super resolution model, because of because of how you're taking an image from here, from this bunch of pixels, and you're already outputting it into what it would actually look like in the human eye, which is a tree that's very detailed with a lot of its branches and its leaves. So here's another image. It's just a baby, and you're just gonna see how the blurs, it's becoming more transparent, it's becoming more clear. You're having that sense of sharpness and clarity to images. So what exactly is image super resolution? So to put it simply, image super resolution is referring to the task of enhancing a low resolution image. So your baby, or for this instance, it's this baby on the left, and you're gonna create a high quality image or a high resolution image from it. So let's just collate from the icebreaker. You had these low resolution examples. You had this little blur and slight pixelation on this bench. You had the lack of focus and the blur that's more blatant in this particular image of the flower. And at the same time, you have the very, very, very blatant pixelation and lack of quality when it comes to the trees. So in super resolution, you're taking these input images and you're trying to output the high resolution variants, which would be what the images would have looked like if you had a better camera, or at the same time, if you were perceiving it from the human perspective. So let's go into the rather juicy bits. These particular images in the icebreaker are just more like scenic, and at the same time, they're not necessarily, how would I say, um, practical applications, because for one, this is more on the leisure side where you're just enhancing the photos that you're taking. But let's try to recontextualize exactly where super resolution can be very useful and very helpful to society. So the first one is actually medical imaging. I'm assuming this does not necessarily need much explanation, but when it comes to X-rays and at the same time particulars, there are particular instances where old technologies such as blurry or at the same time outdated machines would have a more pixelated imagery from their X-rays, from their scans and whatnot. And definitely there's this particular precision that medical fields would actually require. Because when you're operating and when you're looking and when you're trying to assess particular diseases or looking towards the deformities that may be present in terms of the x-rays, you're going to need as much quality as you can, because you don't want to essentially diagnose without having the best capabilities. So that's why super resolution could actually be a particular boon to this particular aspect of the medical field, precisely because of the fact that you're essentially having it so that the particular details that were not captured in your traditional x-rays from your older machines, or at the same time if the machine has malfunction, you're still going to be able to extrapolate and at the same time try to get an idea for what the image would have. In relation to this, actually, there's other applications towards the medical fields. So this is actually microscopy. So there's a little bit of detail to this, so give me a minute. There's a particular, okay, here. So in microscopy, just to be clarifying, this is especially into the fields of the microscope, so microscopic aspects. And when it comes to microscopy, um, there's this particular field, or at the same time particular how would I say this, domain in which they're trying to reconstruct things on a more molecular level. So this is to progress our understanding of the microscopic world and the literal, how would I say, foundational building blocks of everything, society, our cells, and whatnot. So super resolution actually can particularly help in this field because of the fact that the traditional light microscopes are limited towards their low resolutions. So you can have, for example, these are 3D reconstructions, but let's just assume that this was the microscope. You could essentially have it that this is a lot blurrier than what it is that you're seeing on the screen right now. And essentially, there are many variations and many different disciplines and methodologies that are trying to intake the usage of super resolution in order to assist in their reconstruction of these microscopic figures. So I'm just going to mention them in briefly, and I'm not necessarily going to extrapolate much further. But there are actually three types of super resolution in microscopy. So they have their structured illumination microscopy, which is SIM. They have stimulated emission depletion, which is STED, and they have single molecule localization, which is SMD. So SIM is more towards having a twofold. So they're trying to look towards the patterns of the particular structures in order to get a better resolution. And then STED, the stimulated emission depletion, is more towards the ends of trying to eliminate the diffraction. So I'll get into this towards the latter segment of the lecture as well. There's going to be some gimmicks towards super resolution. And then lastly, SML, or the single molecule localization, is more towards improving the resolution using quantitative and statistical analysis. So imagery, actually, it's not just what you can see. There's definitely like particular mapping behind it, such as the pixelations. And as CS students, we kind of know this, that images become parsed into numbers and figures like the RGB and our hex values. So another application, and the more how would I say this, more holistic application that super resolution is particularly relatively used in, is satellite imagery. So in a similar sense, especially for example, satellites and how it's separated and it's high in space, there's the ozone layer, there's the light diffraction from the sun. Satellite imagery in particular is going to be one of the better and the more functional applications of super resolution, because you're taking the imageries that are essential to not only monitoring, they're also essential to defense, because satellite imagery is actually just more encompassing of like very far sighted imagery. So for example, security and defense measures of countries. You also have your satellite imaging as a whole, like weather prediction, or like showcasing the imagery from the top view from a very far place. So for example, as you can probably see, the dots here, they're very pixelated towards this top left. I'm going to annotate. So you have a lot of pixelation towards this top left segment, whereas here you're able to see individually the particular buildings. And then similar scenario to here, and what I would presume is like a power plant of sorts. There's a little more definition into the literal areas of the buildings. So this is a rather darker example of this application, but satellite imagery is also, if you've seen movies, and at the same time, if you kind of are particular with the more, how would I say this, aggressive side of the world, satellite imagery is especially used for drone strikes when you're trying to minimize casualties, or essentially um, trying to locate your enemies. Particular recent and ongoing is still the Russian-Ukraine war, and at the same time, yung drone strikes towards hostile environments ng USA. So I won't be talking about the USA much anymore. The next particular application for super resolution is actually going to be security footage. So this is one of the more common applications of super resolution, or at the same time, what I, at least from my experience trying to research into super resolution, license plate super resolution, because license plates are very simple. It's essentially you have your plain backdrop, and then you have letters and number combinations. So this one is a more extreme example. It's very pixelated. Like the fact that it's here, it's not even like, even the super resolved version isn't as clear as you'd expect it to be. But from these pixels, like you could literally count each individual pixel in this image. It's able to extrapolate and it's able to derive, or trying to hallucinate, that this would be DLC 498, which I'll just do the annotation again. If you can, if you need it, if you need to be guided, DLC 49. Then this is a bit questionable, but you could argue that it's 8. So this particular application is very prominent in, for example, you're trying to locate, if you know your CSI films, this might be a little bit of an exaggeration, but this does indeed happen. The cameras that are in place in cities, like even perhaps in here, medyo in some areas, medyo low quality pa din yung cameras. They're not necessarily up to par with the standard of technology today. You're not able to necessarily capture the right amount of details in order to make out the image. So this is actually where resolution can come into play. I'll actually bring this up, but for those of you guys who own iPhones, I'm not too sure if it's applied to all of the retroactive ones. But I think as of iOS 17, if you take a photo of your classroom board from the back of the class, the image will actually get super resolved. I think that's already like an integration that's happening towards our cameras nowadays. Now they're also incorporating super resolution. I noticed this because I had the instance where my camera on my phone super resolved the words on the blackboard, and it kind of interpreted it wrong. So that's how I realized na, oh, my camera's already trying to super resolve it. So in line with security footage, it's not only applicable to your license plates. It's actually more, it can also apply to human beings. So this does not necessarily need much explanation, but this can also come into play in terms of your filters. Na the computer will be able to recognize that it's your face, and it can also try to blur out yung mga acne mo or whatnot. Like this is where super resolution is also coming into play. So I'll bring this up a little bit later because there's a similar application. So the next particular one, and this one's is actually a rather interesting one. So I'll be playing two videos in back to back, but I just want you guys to notice the particular differences. Um, the volume's not too loud naman, right? Like it can be heard. Well, yeah, I think it's fine either way. So let's just look at this comparison first. Okay, so this is like let's instead of let's okay, sorry. Instead of playing the remaining 3 minutes, I'll just want to bring up the particular things that you might notice. So, firstly, this immediately introduces the concept of video super resolution because as of the previous slides that I've been showing all throughout, the main thing that's been happening is more of a single image super resolution. So video resolution is super resolution still, but it's in towards like video formats. So this is particularly evident in your um, AI upscaled uh, videos and film. So we can go to this particular one. So this is the original. You can see if you'll pay attention towards the planet itself, the one that's colored like Jupiter. In the original 480p 24 fps, it's somewhat a bit blurry. Like it's still really good for considering when this film was made, but if we go to the remastered, you can immediately there. So if I it's 24 and 36, there's immediately a difference in terms of how the bluish segment. So allow me to just annotate. Oh no. Okay, I can't annotate with the video. But that's the particular thing that I just wanted to bring up because like the blue atmospheric segment of here, when you compare it to the this one, uh, sorry. Okay. Um, if you're comparing the two from the original, that's 480p, and the one that's in the 4K remaster, you're going to see a lot more detail and less puffiness on the planet in terms of its resolution. So here, you can actually make out these lines on the planet way better than you could have in the original one because there's still a lot of blur. And at the same time, the detail towards the ship, you're gonna notice that it's a lot sharper than the original. Like here, like you're gonna notice that I forget the name of the holder of the fighter, but essentially that particular like cargo bay of the Star Wars vehicle, it's essentially a lot more refined and sharper than the original. Similar thing could be said towards this segment. So this is the Stormtrooper. And then if you go here, you're gonna notice that it's a lot brighter, like it's a bit more contrasty. And I'm gonna explain that contrast in a little bit. So allow me to just play this second video. So by comparison, and you're gonna notice why there's gonna be a comparison. This one doesn't actually showcase the original footage, but if any of you guys have watched the movie Tron, 2007, Tron Legacy, I'll just play like maybe 30 seconds or like a minute of the upscale version in terms of open math HDR. Okay, so that's probably a really good place to stop. So the reason why I wanted to bring up this comparison is when I was looking towards video super resolution, this was actually the first thing that came into my mind because maybe 1 or 2 years ago there was this trend of like this edit of 4K, Tron, or like other movies from the early 2000s or even the early 90s that were getting super resolved or upscaled. But there's a particular difference that I want to bring up. So allow me to just get my notes. So OpenMat HDR 4K is not actually using super resolution. So there's a difference between the upscaling and the super resolution in that regard. Because OpenMat HDR is more of a formatting based approach that particularly deals with the aspect ratio of the source video. So aspect ratio is going to be like your 4:3, 16:9, etc. Where and the HDR, your high dynamic range, it's more towards the contrast and the color range of the film itself, and not necessarily the particular resolution. The difference is the AI upscaling or remastering incorporates or typically incorporates the usage of super resolution. And instead of just doing the contrast, the number of pixels, it's also trying to improve the true resolution and the dynamic range of the image or a video. So just to cement that, when it comes to like upscaling, there's those that do not make use of super resolution, and there are those that do make use of super resolution. So considering my examples of Tron and at the same time Star Wars, it's no secret that this actually occurs. Super resolution has applications towards movies and entertainment. So this is just a blur of turbo, and you can see it's a lot more refined and a lot more clear, as if it were like a still image from the film. So this also has your applications to your gamings. So if any of you are fortunate enough to have your 4K, your RTX 30 or 40 series, I can just play the video because it's short. You're gonna notice now there's an immediate visual clarity difference. So this is very prominent nowadays with a lot of games. Na if you have a rather powerful GPU, and I think even some games or mechanisms even allow for like I think even 1050 Ti's. I might be wrong on this, but I recall lang na there are some technologies that allow for these kinds of resolutions, even on those lower end GPUs. Well, not lower end. I'm using a 1050 Ti myself, pero definitely considering the advancements in GPUs, you could consider it on the lower end na. But it's still perfectly respectable. So, other applications of super resolution. So this is a bit more of like the supplemental aspects. So autonomous driving, Teslas and whatnot, is the spatial. You have your spatial recognition, you have your computer vision aspects. So super resolution could be an assistance, especially once again towards your camera quality. So for example, um, let's use a more Gen Z type of reference. If you guys know Michael Reeves, if you're doing those kinds of experimental builds with like low quality cameras, you could try to incorporate super resolution in order to assist those cameras in their detection capabilities, and and at the same time their awareness of the surroundings. In a similar sense, you have your robotic vision. So, for example, this is the respect of the vision towards this particular part, and if you can notice, it's a little bit hazy and there's a bit of like line breaks. So super resolution could be used to try to resolve like the particular like gaps and the tracings para you have your accurate like mapping using lasers and whatnot. And also it will come into play in object detection, which if you guys heard my introduction, I'll dwell into this towards the final slide of the lecture. But super resolution could be used to incorporate and assist in terms of object detection. So here is another security aspect. So if not just for your getting your plate numbers, this will help make out the features of particular suspects and crimes. So that's evidence enhancements. And of course, you also have your fingerprint analysis because not only not only would the fingerprinting technologies nowadays be more advanced, we now have the capacity to, for example, you get a fingerprint na medyo blurry or at the same time it's incomplete, you could try to use super resolution to try to fill in the gaps. So last few for the particulars of the applications. And while I'm saying these last two, I'd like you guys to try to think of something that I might not have mentioned because I just want you guys to try to think about what other applications would super resolution in particular have. So deep space imaging, if you guys are familiar with our recent progressions in imagery, we actually have the usage of super resolution because of the fact that, let's just say, it all boils down to the computational expensiveness of how deep space imaging works. Because again, these are light years and literal light years upon light years far away from us. So there's actually a particular aspect that's actually correlated with object detection in deep space imaging, which is your exoplanet detection. So for example, this little planet is actually going to be one of these infinitesimally small dots. And the particular thing that I just want to leave here is that there's currently studies trying to look into using super resolution instead of your conventional imagery because of the fact of the computational costs and like hardware intensity that it would take. Considering how, if you guys know the more famous image that's like more orangey here, if I'm not mistaken, that had like a stack and a stack of like papers or at the same time, like parang so many networks that tried to work together just to generate that particular image. Okay, so now that I've shown you the particular applications of super resolution, I just want to go briefly and discuss how super resolution works to begin with. And in order to do that, I'll actually share the video that got me interested into super resolution in the first place. As in, before I was even in DLSU, or if my counting is correct, yeah, before I was in DLSU, I kind of saw this video from my. So here, it's audible naman. Could everyone react, or like could someone? Please. There's that scene where someone finds a smoke. Is the volume okay? Yeah, okay.
Yes.
Thanks. So let's just play this video. I'll only do up until like 2 minutes 30.
An obscured image, and they get a clearer picture out of it by zooming and enhancing it. Is this really possible? Mostly no. Those movies are nowhere near technically accurate. But to some extent, yes, it is indeed possible to enlarge and enhance images, and that's called super resolution. And that's what we're going to be talking in this video. The process of upscaling and enhancing an image is called super resolution. There are multiple ways to do it, but for now, let's focus on single frame super resolution, where we have a single low resolution image and want to upscale it. So how can we upscale an image? The simplest way to do so would be to spread the pixels out and fill in the holes by copying the values from the closest pixels. That's how nearest neighbor upscaling works. But that doesn't really look like a high resolution image, does it? It looks more like a low resolution image with larger pixels. You can improve it a bit by taking the weighted averages of neighboring pixels rather than copying the closest ones. That's essentially what bilinear and bicubic upscaling algorithms do. But even that doesn't look good enough. In information theory, there is a concept called data processing inequality. It states that whatever way you process data, you cannot add information that is not already there. This implies that missing data cannot be recovered by further processing. Does that mean super resolution is theoretically impossible? Not if you have an additional source of information. A neural network can learn to hallucinate details based on some prior information it collects from a large set of images. The details added to an image this way would still not violate the data processing inequality because the information is there somewhere in this training set, even if it's not in the input image. So how can we train such a model? If you watched my deep learning crash course series, you might be thinking, can't we just train a neural network to learn a mapping between low and high resolution images? Yes, we can, and we wouldn't be the first ones to do so. That's pretty much what the SRCNN paper did. First, we can create a dataset by collecting high-resolution images and downscaling them. Or we can simply use one of the existing super-resolution datasets, such as the DIV2K dataset. Then we can build a convolutional neural network that would input only the low-resolution images, and we can train it to produce high-resolution images that match the original ones the best. The SRCNN paper simply minimized the square difference between the pixel values to produce images that are as close as possible to the original high-resolution images.
Okay, so this is more of an introductory aspect, and at the same time, I myself, I don't necessarily have a particularly high level understanding of super resolution myself. But I really want to bring into the discussion this particular aspect of the how do you call it? Yung sa hallucinations of the details. Kasi if I'm just gonna play this portion again.
Ways to do it. Have a single low resolution image and want to upscale it. So how can we upscale an image? The simplest way to do so would be to spread the pixels out and fill in the holes by...
Yeah, there. So when it comes to single image super resolution, you're really mainly trying to fill in the gaps because you're trying to add more detail and you're trying to get a better idea or a better grasp of the image itself. And as the video would later go on, you have your bilinear, bicubic, or other kinds of interpolations that try to estimate these pixel values using the weight of the surrounding ones. So just to, oops, okay. So I'm just gonna leave it here. So in essence, when it comes to super resolution, you're trying to essentially fill in the gaps, and you're trying to do so through not only the interpolation of what these images might be, but in essence, you're also trying to hallucinate because, for example, when you have super resolution models, typically they're already trained, and what's happening behind the scenes with your training is you're actually getting all of these high resolution inputs, and you're just trying to train your super resolution model to be able to extrapolate such features from your low resolution inputs. So these are just a few of the methodologies and techniques when it comes to super resolution. You have your pre-upsampling, post-upsampling, residual networks, multi-stage residual networks, recursive networks, progressive reconstruction networks, multi-branch, attention-based, and generative models. So for this particular lecture, I'm just going to somewhat highlight and emphasize on the first two, which is the pre-upsampling super resolution and the post-upsampling super resolution. So give me a second. Okay. So pre-upsampling resolution is more essentially the process of you're upsampling first before you you're upsampling first in order to match the dimensions of your desired high resolution. So in essence, you're going to upsample the image first, and then you're going to process it by a deep learning model for the enhancements and the reductions of artifacts. So I'll try to delve in a little bit and expand on the images of the SRCNN and the VDSR models later. So the particular advantages of pre-upsampling is more how it's simplified learning for your neural network. And at the same time, this is a bit more compatible to pipelines that already have particular specifications for your input. However, there's a drawback because of the fact that if you're already going to upsample it initially, since you're not adding hallucination just yet. You could probably introduce like artifacts or blurrings that could affect your super resolution. And at the same time, you also have the issue with your larger images because these could increase the computational load and the memory usage of the program. So this is SRCNN. Essentially speaking, let's just take this at face value. So from your low resolution image input, you're going to have three particular layers. You have your layer for patch extraction and representation. Then after that, you have your non-linear mapping layer. Then you have your reconstruction layer. So I'm going to be annotating in this particular segment. So in your patch extraction, you're essentially trying to take your high density patches from your input image, and you're trying to represent them using your convolutional features and filters. And after that, you're going to have a non-linear mapping. Okay, I shouldn't really annotate on that. You're going to have your non-linear mapping, and after that, you're going to have your reconstruction of your image in order to get a more high resolution image output. For VDSR, or what is called very deep super resolution, this is essentially, it's a little bit of an improvement towards the SRCNN, and it's more revolving around the addition of a deep network with addition of small convolutional filters. So essentially, in respect to this, your where is it? So by contrast, you're essentially having it so that the network will learn the residual of the output image and interpolated input rather than learning the direct mapping. So if I go back here, you have your mapping here in this aspect. It's already trying to learn it from these particular steps already instead of just having a mapping stage. For post upsampling naman, it's in contrast, instead of doing the super your LR image is essentially directly fed into the deep learning model. So the extraction and the reconstruction will be happening more actively because you're essentially having an internal upsampling within the, oh, that's a catastrophic type of network using your learnable layers. So we have FSR CNN and ESPCN, and you have your advantages that it's a bit more optimal in terms of how the model learns these upsampling kernels, which would potentially lead to better reconstruction quality. And at the same time, it's going to reduce your computational complexity and memory requirements. However, as it might not be, or sorry, as it might be obvious from this, because of this more live, active aspect, it's going to require a bit more of a sophisticated network of architectures and training procedures. And this may actually make it necessitate a bit more computational resources for training. So we actually have this, so this is FSRCNN, so faster, if I'm not mistaken, that's fast, yeah, or FSRCNN and SRCNN. So the main particular difference that you're going to immediately notice is that there's no pre-processing when it comes to FSRCNN. And apart from the fact that you have your patch extraction, nonlinear mapping, and reconstruction, in the FSRCNN, you have feature extraction, shrinking. So you're going to take it from your 5x5 convolutional layer, and you're going to turn it into you're going to feed it into a 1x1 convolution. So that's particularly the shrinking aspect is going to be the reasoning for why there's such a reduction in the computation and memory aspect. So you're going to go through this process. You're going to now map it and expand. Essentially, after you're done with your mapping and expanding, you're going to run into a deconvolution. Sorry. you're going to be running into a deconvolution. So it's a bit more complex because you're essentially running into um, uh, multiple feature maps in comparison. So for example, you have here, you only have 2 feature maps in SRCNN. Here, you're going to go through it roughly 4 times. And what's essentially going to happen is through your deconvolution filter, this is where your upsampling is going to take place. And this is where the high resolution image will particularly be derived from. Then the last one, ESPCM. Essentially, what I mainly want to drive along here is the aspect of the overlap and the information. So let me annotate. So you're particularly looking towards the areas na they're all intersecting. So you have a size 2, you're looking at towards these darker triangles. And at the same time here, size 3, you're going to look at the ones with more significant overlap. So essentially, you're having your low resolution image inputs, and then you're going through another set of feature maps, and then you're going to have your subpixel convolution layers. So I could provide links naman towards all of the sources that I used if you guys are a bit more interested in looking into the more specifics. But I just realized I'm kind of pressed for time, so I'll try to hurry along with the presentation. But the next particular aspect of the presentation is actually the gimmicks of SR that I teased earlier. So the fun thing about super resolution is that it's actually a matter of training. And this particular paper was one of the more amusing ones. And I just want to highlight the particular aspect of super resolution when it comes to this particular example. So the main thing that you're going to notice from a human perspective is the real emphasis of the concept of hallucinations. Because at least from the human eye, let's take this as the HR, because this is the high resolution image, and this is the low resolution pixelated image. What you're going to particularly notice is the fact that we have a bird in this slide. We have roughly what looks like a bird or a mammal. Then you have all of these different variations of how the boat looks like. For example, you have it here. This is what it looks like. It's a yacht. And then you have what is like a ship or yung parang, how do you say, transport cargo ship-esque here. And then the middle ones, you can particularly notice that they're a bit more of like amalgamations of like ship hybrids that have a rather janky type of layout. So super resolution actually is not as straightforward as it seems. And there's definitely like from my breadth of research into the particular super resolution history, there are so many particular layers and trainings being done towards super resolution models. Now, for example, this particular one, um, let's just blanket term it. You're going to train a model to super resolve, and what you want to achieve is this boat. So immediately what you're gonna do, the minute you run into this, for example, you're gonna say, no, you don't, excuse me, sorry, was that heard? You don't want it to do bird. So you could immediately try to say na, okay, try not to generate a bird. Then it could generate this. And you're gonna say, okay, try not to generate this particular texture or something like that. Like you're going to describe na, oh, it's going to be a boat. And then you can have all of these little gimmicks. And then you can arrive to this one, which although it's a bit high quality, it's not necessarily the exact one that we're able to look at. So similar happenstance can occur over here. You have your zoomed low resolution of this window. What you can probably see is, I'll probably just highlight it, but the particulars in terms of like the frames or like the skeletal parts of the window, the different super resolutions actually have varying degrees of how they're reconstructing it. So a particular thing that if you're going to look into super resolution on your own, a particular thing that you're going to notice is that a lot of models are able to perform well, but they all have a different degree of accuracy or at the same time like sharpness when it comes to super resolving images. So you have Here's another one from one of the papers that I've seen. So I'll annotate once more. You have your high resolution, which is amalgamation of wires. And then this is the bicubic, the one without any hallucinations or what. You're just filling in the gaps. It's especially blurry. So that's one of the main particular gimmicks of SR, is that if you're just using the really basal or primal forms, you're really just gonna get a bit more of a blurry because you're essentially just having more pixels, but it's not really resolving your issue with the resolution aspect. So you'll see that towards these other variations of actual super resolution algorithms, you're going to have a variation towards, for example, this one is a lot more detailed in the roots. Then this one is a lot more highlighting towards the particular like layers. So if you're going to notice, this particular line is like highlighted in white here, whereas in this one it's grayish, like it's not necessarily like pointed out. So you can see that there's a variation towards how the super resolution algorithms are essentially hallucinating the details. And another gimmick of SR that will be especially more blatant is in this particular image of this balcony of sorts. So once again, you have your HR, you have your high resolution image. You're actually going to notice, especially from the enhancement, is that super resolution can actually result in a still blurry image because it's not able to particularly pick up the how would I say this? It's not able to particularly pick up the true depth or like the layering of the image. Because for example, in the higher resolution, you could immediately notice that this is like a little extension of the lower wall, like this is like a staircase. But in enhanced net, it's not able to necessarily discern that just yet. And a similar occurrence actually happens in all of these because you're gonna notice it just merges into, like it's not necessarily seen as a particular gap. Like it's only particularly noticed in this one, but it's not. This one now has a flaw in terms of how it's not necessarily straight. But you're gonna notice it has a little bit of curves and like disfigurations, and that's a particular aspect to super resolution that I just want to highlight and emphasize. So another gimmick when it comes to super resolution is is more towards the details aspect. So I won't be annotating anymore. But if you guys are able to notice how the different variations of the models take on this castrol text. So you're going to notice how when it comes to the aspect of trying to fill in the gaps, there's various implementations and various takebacks. That the best one is arguably, at least from the human eye, you could say it's the WGSR because you could somewhat make out the STROL, and at the same time you could somewhat make out the A slightly, compared to something like the ESR GAN that's a bit more like loops and squiggles. So these are particular gimmicks when it comes to super resolution, which is why, in particular, when you try to come across or look into the more modern, let's say 2024 IEEE, I'm not too sure if there's 2025, probably not, pero you're going to notice there's going to be a lot of technical jargon when it comes to the super resolution models and the accuracy that they're doing. Because a particular issue that a particular issue and gimmick that's going to encompass all of the images that I've shown so far is the particular how do I say this, perception quality balance of super resolution. So I'll just introduce this insight to you guys. But I've been talking about super resolution for like the past hour, and the main thing that I want to drive is the fact that when it comes to super resolution, you're not only trying to make the image as faithful to the original as possible, but you're also trying to balance it with the fact that the human eye will see it as natural. So what exactly will that necessitate. So I'll go back here just for a brief period. The rightmost image that I was kind of blaming for the fact that it's not necessarily the same as the original image. While it's not the original image, of all of the super resolutions present of this particular boat, you could immediately argue that it's actually the most natural looking. Because from a glance, like let's say you just had a really blurry image of this and you didn't know what the high resolution image actually was, you're able to actually perceive and have that opinion that, oh, this is a really good super resolution because it does not look jarring. Like it doesn't look like a random pigeon that's humongous on the ocean. It looks like a boat that you could somewhat assume that, hey, this came from this low resolution image. So super resolution is actually having that particular issue right now, where people are still trying to balance talaga yung quality of the upscaling and the mapping of getting the high resolution output from a low resolution input while maintaining that sense of naturalness na it's able to be perceived as something natural. So it's actually time, but I'll just briefly So why exactly would I discuss super resolution to begin with? And just a little brief teaser to what my thesis topic is about. So object detection is the capacity for a computer to essentially view objects. So for example, you have this image, it's able to view this taxi as a car and it's able to put them in bounding boxes. So a lot of object detection algorithms, they're always seeking towards improving their capacities to detect these particular objects within the image. The super resolution inquiry that I'm having is more towards, as opposed to improving the object detection capabilities, why not improve the input image itself? So you're having that inquiry that the progressions of object detection algorithms nowadays, they're mainly towards improving their own capacities to detect. And the inquiry that I'm trying to look into now is, why not try to attack it from the dimension of the input image itself? So um, that's particularly why I'm interested in super resolution to begin with. Because, for example, I can immediately just highlight, you could probably notice that there's an ambulance way back here in this image. I probably should annotate, I pointed it physically here, but it's not detected by the object detection. So a particular thing about object detection algorithms is, even the state of the arts, more often than not, they're not necessarily able to detect the far away objects, because far means you have low pixels. There's not really much to make out of the silhouette. And that's where super resolution could be a really nice potential, how would I say this, fix to the problem. Because if you're able to super resolve it enough that it gets detected, I think that's a really promising how do I say this, pursuit in terms of progressing object detection. Because in terms of both object detection and super resolution, more often than not, if you're going to look at the improvements nowadays, 2025, 2024, you're going to see a lot of layers and complexities. And I find it interesting na, what if you're combining the best of both worlds in order to progress on one particular hindrance or one particular weak spot of the task? So just to recap the talk before I end. So what I've discussed right now is essentially super resolution, all of its various applications. And actually, while I was discussing, I kind of realized one other application that I didn't bring up is actually art restoration. So I'm not too sure if you guys have seen those videos of restoring art. Super resolution could actually make a difference there because of its capacity to hallucinate the details. So for example, you have a degraded piece of art, you have your art restorers, and at the same time, if you want to be a bit more meticulous and calculated, you could essentially employ the usage of super resolution in order to like get the finite, like absolute areas where you need to restore. So that's just a fun little addition. So we discussed the applications. We've also discussed a little brief introduction to how super resolution works. and a little input towards like the particulars with respect to the pre-upsampling and post-upsampling super resolutions. And then I've discussed the gimmicks. So just to put it bluntly, you have your gimmicks in terms of trying to balance the naturalness of the super resolution. You have your gimmicks in terms of how the hallucinations may be different from what the human eye would perceive from the original image. You also have that hindrance of the lack of depth perception, because sometimes it's going to merge particular details together, despite the fact that if you're a human and you're going to see it, you're able to discern that it's not necessarily meant to be combined together. And with that, I'd just like to end my talk and say thank you guys for your attention, and I hope that you were able to take something from this lecture. Um, I hope that if you are particularly interested in super resolution, you'll be able to find a little bit of beauty towards its applications. And at the same time, if you guys are able to witness, for example, in your games itself, you're able to really appreciate na there's this particular technology behind all of these enhancements that enhance your gaming experience or your viewing experience, because super resolution is not only being integrated into these particular technologies now. I think especially with the application into your iPhones or even your Androids, I think Android's also incorporating it now. Super resolution is becoming a bit more prominent in terms of our capturing imagery and at the same time our camera applications. Thank you guys.
Thank you, Ricardo, for that very good presentation about super resolution. Any questions from the group? I actually had some questions before, but you were able to answer those questions already, especially about the bicubic interpolation. So remember before super resolution happened, the way that we enlarge our images is usually using those bicubic interpolations, no? Just filling up the gaps in the pixels. Any questions from the attendees? If you have no questions, can you please thumbs up? Okay, thank you. Thank you again, Ricardo. Let me just share my screen for a while.
Nasa gaba. Thank you guys.
Okay. Thank you again to our speaker, Ricardo, for sharing to us what super resolution is all about and showing various examples. Hopefully that got you excited into doing some super resolution topic in the future. For our next presentation, this would be next week. This is actually the final academic lecture for this term. The title of the presentation is An Introduction to Residual Learning for Computer Vision. This would be presented by Aaron Dichoso next week. So that would be March 12th, Wednesday, same time, 4 p.m. And it will still be online via Zoom. So if there are no more questions, again, thank you to our speaker, Ricardo. Thank you everyone for attending. See you again next week. Ingat kayo and have a great week.